All right, so I want to first of all start by introducing myself. Although my picture is not appearing there, but my name is Mira Kuchibuze Marcel. It's displayed on my view, and I am the founder and the director of the Pan-African Citizen Science E-Lab. And in our organization, what we specialize is in astronomy research that ordinary people can do. We call them citizen science. So I'm going to give a lecture on these asteroids, okay, that we research upon, and also talk about the asteroid search citizen science, and also talk about uh, planetary defense mechanisms. So first of all, I would like to show you this this animation. This is an animation of the formation of the solar system. Okay, after the formation of the sun, it was the protostar. So there were other materials around it. Okay, we call that the molecular cloud. Okay, but in this case, you can also call it the debris disk. You can call it the debris disk. Let me start it from the beginning. Okay, look at it here. So this is called the debris disk. So this debris disk is responsible for the formation of the Oort cloud, the asteroids, even the planets, okay? So after the formation of the solar system, after the formation of the sun, after the formation of the planets, okay? Now the leftover formed the asteroids and the Oort cloud. So let me play it again. So look at the exact depiction of the formation of the solar system. So you would see the planet will begin to form. And as these planets are being formed, they become bigger and bigger. Oh, sorry, I touched it. As these planets are being formed, they become bigger and bigger, and they amass more mass, okay? They become more massive and they attract more materials. So that is how they were able to clear the orbit, okay, around the sun. And that is exactly how you have the solar system. Now, there were objects, there were materials that could not form planets. So those ones became the asteroids. Some of them also became the 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 Oort clouds and the comets, but our focus is on the asteroids. So this is going to, usher us into the real meaning or the picture of asteroids. So let me play the video. Let me play all the videos so you can see the formation of the solar system. You can see the planets are all fully formed. So that is exactly how planets are formed, not just our solar system. So now introducing asteroids. What are asteroids? Now, there are no definitive definition of asteroids, okay? But we can say that asteroids are class of smaller bodies that are rocky or metallic that orbit the sun out to Jupiter, okay? Those smaller bodies that are not planets, okay, that you can find from the sun. If you start from the sun, you move out to Jupiter, those are what we call the asteroids. Now, asteroids should not be confused as comets. Comets are different from asteroids, okay? Comets have tails, okay? But asteroids do not have tails. Comets are coming from the Oort cloud, but asteroids are in the main belt. So I want to make a distinction between the two. And also I want to make a distinction between asteroids and meteoroids, okay? Asteroids are like the bigger bodies. I hope I'm there. My screen has frozen. Hello, tell me if I'm communicating. Okay, but my screen has my camera. Let me activate my screen again, just a moment. Let me, uh, okay, good, good. So I'm so sorry for the interruption. So I actually thought that the network has cut me off. So, okay. So, back to what I was explaining. So asteroids are different from meteoroids, okay? Asteroids are the bigger bodies, okay? Bigger bodies. Asteroids have specific sizes. For instance, asteroids range from 1 meters to 1,000 kilometers, okay? But we have other smaller bodies that are as a result of collision. So if you have these bigger asteroids, okay, no matter their size, when they collide, they break into other pieces, or maybe you have two comets. When they collide, they become smaller in size. So those are the ones we call the meteoroids. So meteoroids are often remnants of asteroids or comets that can originate from collision or the breakup of larger bodies. So understand it too, meteoroids and asteroids and also comets. Now, what is the history of the discovery and the observation of this asteroid? Now, in the early 19th century, astronomers have discovered most of the planets that we know today in our solar system. Okay, but let's look at the diagram here. This is Jupiter and this is Mars. Okay, now the gap between Mars and Jupiter is quite wide. Okay, so they wanted something to be there. They wanted a planet to be there. So they started searching, they started to point their telescope in that direction. I know from orbital mechanics, you can calculate the speed of any object that are likely going to be there. So they started to discover some bodies. So they call it asteroids. So meaning star-like. So around that area, it is moving at the speed that they calculated. Okay, so they call those things asteroids. So in 1801, Ceres was discovered. That is the first asteroid. Okay, and now Ceres has become the largest asteroid that we know. Okay, and also Ceres is the largest um dwarf planet that we also know. So Ceres is an asteroid. So discovered in 1801, and as they continue pointing their telescope in that direction, the belt, they they discovered Pallas in 1802. In 1804, they discovered Juno. 1807, they discovered Vesta. So as of April 2022, they have discovered more than 1 million asteroids. So this is the animation of those asteroids that have discovered, okay? This is the animation. They have discovered up to 1 million. But in theory, we believe that there are about 1 billion asteroids. So now, what are asteroids composed of? So we have three composition and classification of asteroids. So we have the C type, we have the S type, and we have the M type. The C types are carbon-based asteroids. So they make up 75% of all the asteroids that we know. Okay. Then we have the S type, the silicon-based. Silicon is like sand. Okay. They make up 17%. And then the other 8% are miscellaneous. They are predominantly metallic, okay? So we call it miscellaneous. Some people say it is metallic, but we just call it miscellaneous because not only metallic, we have other materials that make up 8%. Then we have mean distance between asteroids. Now, if you look at the typical pictures of asteroid belt, this is the asteroid belt. The typical pictures you see on the internet, it is drawn like this. Asteroid belt is drawn like this. So from this, you might think that it is compact. I mean, there's no spacing between one asteroid to the other. It is compact, and but in reality, uh, they are widespread. Okay, space is very big, so the distance between one asteroid to another asteroid is over millions of kilometers. So if you are standing on top of one asteroid, you may not even be able to see the other asteroid. So that is how empty the asteroid belt is. So we can safely, move the spacecraft, okay? Like the Juno spacecraft that explored Jupiter. We also have the Voyager. They all pass through this asteroid belt without being hit. So space is very big, and the asteroid belt is not really like that. Okay, so I want you to know that. Then we have the mass. I hope you can see this. This is blocking my screen. Let me bring it down here. So we have mass, size, and density of asteroids. Now, if you look at this picture of asteroids, if you look at this, let me, if you look at this picture of asteroid, they look quite many. Yeah, asteroids are many, millions of them, okay? But to your surprise, these asteroids are not, if you clump them together, if you bring them together, okay, they are not even up to the size of the moon, okay? They are far, far, far less than the size of the moon. And like I've said before, the sizes of asteroid, they range from 1 meters to about 1,000 kilometers. That is the range of series. Okay. Now, if you measure the mass of these asteroids, okay, the whole asteroids, all these asteroids everywhere, if you measure the mass, they are just about 3% the size of the moon, just 3%. So asteroids are not really that massive, okay? They're not really that massive. So if you look at them, they look like, rocks. They look very solid. When we look at this asteroid, we compare them with the rocks on Earth, but in reality, they are not as hard as the rocks we have on Earth. They are loosely packed, okay? And they are of low density. So now, how about the distribution of asteroid within the solar system? So let me talk about the distribution under main belt asteroids. So this is the picture of the main belt asteroid. This is the picture of the main belt asteroid. It's like somebody is communicating in the chat. Just a moment, let me check. Okay, good. All right. So look at the picture of the main belt asteroids. So this is the main belt asteroids lie between the orbit of Mars. This is the orbit of Mars to Jupiter. Okay, so that is why you have the main belt, and it is even written there. Okay, now these asteroids, they have low eccentricity. Okay, let me give you an idea. A circle has, perfect circle. Circle is perfect, okay? Not the one you draw. The theoretical circle has zero eccentricity. So if you hear that something has low eccentricity, it means that it is almost like a circle, okay? So they have low eccentricity around the orbit, and the orbits are unique and they are quite stable, okay? They are unique and stable. What I mean by unique is they are not crossing the orbit of other planets. I will show you that when we talk about near Earth asteroid, because near Earth asteroid crisscross the orbit of other planets. They are unique, they have their own specific orbit, okay? And they are quite stable. Then if you look at the period, if you look for the asteroid that are very closer to the moon, sorry, to Mars, okay, their period is about 3 years. Takes them 3 Earth years. to go around the sun, while the ones that are outer here are up to 6 years. So that is just the average, okay? You can have some asteroid that may be taking longer or even shorter, okay? Then we have the distance. For these ones here, their typical distance is about 2.1 astronomical units. And these other ones here are up to 3.3 astronomical units. These are just, approximations. So if you calculate the distance from here to here, the distance from here to here, if you do the math, that should give you about 1.2 astronomical unit. And what is astronomical unit? Astronomical unit is the distance, the unit we use in astronomy. It simply means the distance between the Earth to the sun, okay? Or from the sun to the Earth. So from the sun to the Earth, we call it 1 astronomical unit. There are other units, okay, but we just use this as a standard, okay? So if you hear of something like 1.2, so that is slightly above the distance from the Earth to the sun. So that is, so you can imagine, I want you to have an imagination of how spread out, how wide the main belt asteroid is. It is quite wide. It is not a thin line, it's a wide space. Then let us talk about Trojan asteroids. We are still on the distribution within the distribution of asteroids within the solar system. Then we have the Trojan asteroids. What are these Trojan asteroids? Let me first of all explain the Lagrangian point. Now, if you have two systems, let us say the Earth and the Sun, okay? I mean, forget about any other planet. Let's just imagine you have the Earth and the Sun, okay? Now, within these two systems, there are 5 points where gravity cancels out, okay? Now, we call these points the Lagrangian points. There are about 5 of them, okay? I mean, like I said before, gravity cancels out, okay? Now, once an asteroid enters there, it experiences no gravitational pull from any system, not from the sun and not from the Earth. So it stays there, they remain there. So we call those asteroids the Trojan asteroids. Okay, so Jupiter has the most of these Trojan asteroids. Okay, so these are the Trojans. Okay, so imagine this is Jupiter or Earth or any planet. So this is the Trojan asteroids. So if you draw a straight line, like my mouse, okay? I mean, if you draw a straight line, okay, and you trace the angle, it is about 60 degrees, okay? And this one is 60 degrees. So if you have a planet, these Trojans are 60 degrees ahead of the planet in the orbit of that planet around the sun. And we have this one 60 degrees behind. Okay, so Jupiter has the most of these Trojans. I mean, Jupiter has over 1 million Trojan asteroids. Okay, then we have Mars has about 9 of these Trojan asteroids. Neptune has about 28 of these Trojan asteroids. Uranus has about 2, and Earth has about 2 also, Trojan asteroids. Then we have the near-Earth asteroids. Now, remember what I explained from the main belt asteroid. I told you that they are quite stable, but sometimes 2 asteroids can collide. When 2 asteroids collide, or maybe an asteroid and the comets collide, or maybe some gravitational attraction between Jupiter and the asteroid belt, okay, or maybe Mars, okay, that could be some gravitational interaction. So they might leave their stable orbit. Okay, they might leave that stable orbit, and now once that changes, they might start, their eccentricity, the eccentricity of their orbit might then increase, becomes more elliptical, okay, X-shape, more elliptical. So in that case, they might start to crisscross the orbit of other planets. They could crisscross the orbit of Jupiter, Mars, Earth, Venus. But the one that is of importance to us is the near Earth. So those ones that are crisscrossing the orbit of Earth are called the near Earth asteroids. Okay, so look at the depiction. These are the orbits of this near Earth asteroid, the blue lines. So they are always crisscrossing the the orbit of Earth. There's no problem with that, but the problem arises if I mean if Earth is approaching and an asteroid is also approaching, and maybe they hit at the same point, that becomes a problem. So it becomes a very, very dangerous situation. So, like I said, they are highly eccentric, like they are opposite of the main belt asteroid. So, as of April 2022, we have discovered about 28,772 of these near-Earth asteroids. And that will lead us to citizen science, because we need to find these near-Earth asteroids, okay? Because they are very dangerous. Something bad happened to the dinosaurs 66 million years ago, okay? The asteroids, they were hit, okay? Okay, let me explain the dinosaurs, sorry. Dinosaurs, I made a mistake, dinosaurs. Let me explain the dinosaurs. Just like humans are dominating Earth now, I mean, we are the most dangerous beings on this planet right now, okay? So we are dominating Earth, and we are smart enough to develop space program. That is why we're able to understand this. Now, 66 million years ago, the dinosaurs dominated the Earth, but there was no space program. They didn't have any space program. They were only animals which have not developed. Okay, so when an asteroid and Earth are coming, want to occupy the same volume, okay, the asteroid will hit, they will collide with each other, and that is exactly what you have. So the dinosaurs were annihilated by the asteroids, the near Earth asteroids. So the Earth was wiped off. That was the Cretaceous period. I mean, 66 million years ago. Okay, like I said before, this is going to lead us to planetary defense and citizen science. Of recent, uh, uh, in let me move this. Of recent, in 1908, in Russia, this area in Siberia, it is like a forest area, like thick forest, okay, full of life, trees, life forms, okay. The asteroid, when it impacted, the heat from the event vaporized all the trees, made, turn the whole place into a desert. Meanwhile, this place is as large as London, okay? So so you can see what asteroids can cause. So that is why it is important, why everybody should get involved in citizen science. Then in 2013, this time I was preparing for my university entrance examination. It happened, an asteroid in the daytime, you know, hit Earth in Russia, the same Russia. But the problem with this is it came from the direction of the sun. And if something is coming from the direction of the sun, you won't be able to see it. But hopefully, it did not hit the city area. It landed in a very remote area, okay? Very remote area from the city. And I mean, the remote area, because in Russia has some land masses entirely covered by ice, okay? The ground might be water, rivers or sea, but it is entirely covered by water, by ice. So this asteroid landed in such a place and pierced through and went deep into the water, so we could not get the samples. However, the shock wave from this event, when it went off to the nearby city and destroyed a lot of properties and injured about 1,500 persons. We did not account for any death, no death, but it was only injury from shattering glasses and collapsing buildings. And properties worth billions of dollars were lost, we are destroyed. So in 2020, after the COVID-19, an Indonesian man, according to the newspaper, he was described as a poor man, but I don't like describing people like that. So he was in his home. I heard a large sound. Okay, so when he came out, he saw he saw a hole that has been created on his roof, and he looked down and he also saw that whatever might have fallen has pierced the ground. So he dug it up. So it was an iridium material. Okay, an iridium is a rare earth material. So he could find buyers. He sold it for about 2.5 million. I can't remember, but it was in millions of dollars. So he became a millionaire overnight. He built coffin. That is his occupation. He built coffin. So some of these asteroids are made up of rare earth materials. I mean, some, not all. Then in 2022, okay, an asteroid landed in Europe, okay, but fortunately enough, it did not land in a city area. But if we keep having these occurrences of asteroid landing here and there, one day it's going to land in a large city area, okay? So that is why we are, calling on students to, calling on stakeholders to, people in the STEM fields to get involved in this asteroid citizen science project. So since 2013, till now, there has been a number of surveys that have been set up by different government agencies, Japanese, American, Europeans, okay? They have built space programs, space telescopes, and they have also built ground-based telescope to be scanning the sky, like a security CCTV. They are always scanning the sky, monitoring and searching for these these near-Earth asteroids, okay? And in Africa, we happen to be participating in this project. So the data that we collect are from the Catalina Sky Survey and the Pan-STARRS. Catalina and the Pan-STARRS. So we have the New WISE. New WISE is a space program. We have the Atlas. Atlas is in South Africa. It's used by the South African Astronomical Society. Okay, we have the Japanese Space Guide. So the data we use in our asteroid search are from these two telescopes. They produce a huge amount of data. Now, we have this group called the International Astronomical Search Collaboration. They are responsible for distributing the data across the world. So you register, your organization registers, and you get the data. So the Pan-STARRS, this is the Pan-STARRS telescope, send the data, and the Catalina, they send the data to Isaac, and Isaac distribute the telescope, the data to across the world to organizations. So we are collaborating with Isaac, and we get this data. Every month we search for asteroid. And guess what? We use this asteroid search as a tool for promoting astronomy in Africa. So we are doing many things. We are participating in planetary defense, and we are also using it as a tool to promote STEM education, especially astronomy in Africa. And here is the software we use for the research. We call it astrometrical software. And here is how it works. We take images, okay, at different time intervals, 45 minutes, okay? These images are taken at 45 minutes intervals, okay? Take it 4 times, 45 minutes, then you combine them. If you combine them, use software like Astrometrical to run it, and you have this kind of situation. So you can see clearly how the asteroids move in the background stars. These darker spots are the background stars, okay? And the moving object here is the asteroids, okay? So that is how we discover these asteroids. Now, I want you to know something. There is an automatic pipeline for discovering asteroids, okay? There's an automatic pipeline. Okay, you can use robotic, you can use computer algorithm to discover asteroids, but they are not perfect. Okay, sometimes they miss on some of the data. So those other ones that they cannot detect, they cannot detect easily, are sent to humans like us to search. So we started this program since 2020 December, and we have discovered up to 30 asteroids. Okay, mostly main belt. We have discovered this. Look at this asteroid. So look at this asteroid. main belt. We are searching both the near-Earth asteroids and the main belt. We are searching every kind of asteroid that are moving in space because we want to know their whereabouts. Because if it doesn't hit Earth now, it might hit Earth in the next 100 years, according to their instability of their orbit. I told you this near-Earth asteroid, the orbits are not stable. It changes all the time. So it could hit Earth next 200 years, 300 years. So it is always good and important to monitor the orbits around the sun. So in Africa, like I told you, we have been participating in this program for the past 3 years, and we have used it to engage with teachers, students, and space enthusiasts from over 40 African countries. And you can see the map there. The countries in the blue line are the countries that we have engaged, and the ones in white, we haven't engaged them yet, and we are looking forward to engaging them. So now, planetary defense. Now, you might ask, if we discover asteroids, what are we going to do as a human race? What are we going to do? So, and the answer lies in the planetary defense. So we have 5 planetary defense mechanisms. We have 5 planetary defense mechanisms. We have the nuclear impactor. The nuclear impactor. Okay, what comes into your mind? You think we're going to blow it up? Not really. That is an idea from the Hollywood, from the United States movie industry. If you blow up an asteroid, you are making it more dangerous. Assuming an asteroid is approaching Earth and you blow it up, you are making the situation more problematic. You are not solving the problem, you are creating even more problems. So the idea is this. Now, I want you to picture this. Some of these asteroids, not some, most of them are frozen. I mean, they have some gaseous materials, gaseous elements that are frozen. Okay, they are frozen in a solid form. Now, if heat is applied, they vaporize. Okay, so the idea of using the nuclear bomb is this: nuclear warhead. So as the missile is approaching the asteroid, we blow it up. We don't have to hit it to blow it up. We just blow it up, maybe few distances from the asteroid. We blow it up. Then the heat from the explosion is going to melt, or it's going to vaporize these solidified gaseous materials. Now, once that happens, they vaporize. They act like and when they're vaporizing, they act like a jet. Okay, jets, like rockets, jet engines, okay? Like they start creating these jet mechanisms, and that is enough to push them out of their major orbit that are supposed to hit Earth. So that is the idea of the nuclear impact, and not to explode and shatter it, because if you explode this asteroid, they're going to come to Earth in pieces. Now, what if some of them did not burn up in the space? I mean, in the atmosphere. It becomes, so you create even multiple hits on Earth. So it is not a good idea. So that idea of exploding asteroid is from Hollywood, not scientific idea. Then we have the kinetic impactor. The idea is this. So imagine that you have an asteroid, okay? Now, this is coming from orbital mechanics, okay? If the speed of an object increases, it increases in orbit. If the speed decreases, it decreases in orbit, okay, relative to that body, okay? So if an asteroid is coming, okay, about to hit Earth, and here is the kinetic impactor, and maybe we can imagine we hit a spaceship on it. We hit a spaceship on it. I hit it. So we want to slow it down. And when we slow it down, it decreases in orbit. So it changes. We want to change the orbit. We want to move it away from hitting Earth. So we actually did it. This is the double asteroid redirection test. It was tested in 2022, if I can remember. This mission was launched in 2021, and it was tested in 2022. Yeah. So it worked. In fact, it worked more than we expected. So this is the most practical, I mean, out of the 5 that I'm still going to explain, this is the one that we've tested. This is the most potent, okay, way of removing asteroids. So hit a fast-moving spacecraft on it, you slow it down, the orbit changes. Then we have let me move this so that you can see. We have the gravity tractor. The gravity tractor, let me explain this. Now, in space, if you have 2 objects like this, if you keep 2 objects, if you're an astronaut and you keep 2 objects in space like this, within some few minutes or a few seconds, they're going to attract each other. If you do it on Earth, on your table, that is not going to happen, okay, because of friction. But in space, within some few minutes, they're going to come together, okay, because they have this gravitational attraction. Every object has gravitational attraction, gravitational force around it. So imagine we fly a space, human beings are controlling it, or maybe it is, remotely or operate like a drone. So imagine that we have an asteroid, you have a spaceship, okay? Now, if you bring the spaceship, as this asteroid is, orbiting, maybe in the next 5 years, it might hit Earth. So we want to start deflecting it now. So if we bring it closer to the asteroid, if you drive it closer, okay, the asteroid the 2 will attract themselves according to Newton's gravitational law. So, but as this is a man,
Marcel, we have a problem. We have a problem?
oh,
Yes, yes.
sorry, I have not finished present. I'm almost done. Just some few minutes. I'm almost done. Sorry for what happened. I was very surprised. I was cut off.
Yes. Don't worry, Just continue. Without any problem. Okay, just go on.
Okay.
Don't worry if you have any technical problem. Okay?
Okay. So, like I was explaining, so if you have astronauts in this ship, they move, okay? As they move, you have this other one, this asteroid following it. They are attracting themselves through gravitational field, that mutual gravitational attraction. So that is how the gravity tractor works. We have not really experimented. It is just theoretical, okay? But I think it's going to work. No, before we fly anything there, we have to theorize it. Even this DART mission was theorized before we did the experiment, and it worked. Then we have the laser beam. The laser beam works like this nuclear impactor. I mean, the mechanism is like the nuclear impactor, because remember, in this nuclear impactor, we talked about the work of heat. The heat, vaporizes the solidified gases, okay? So in this laser beam, okay, so we have a satellite with a laser orbiting Earth. We launch a satellite and it will be orbiting Earth, and an asteroid is approaching. We will aim it at that asteroid, okay? We aim it. Now, when we aim the laser on that asteroid, the laser is going to heat up the solidified gaseous element, okay? And that gaseous element is going to to vaporize and produce those jets of materials, like I explained before. So that is going to move it away from the change orbit, and it moves away from hitting Earth. But the only danger is this: what if it malfunctions? What if it malfunctions? So maybe imagine that an asteroid is approaching Earth, maybe, and it maybe took you months and months to build a spaceship, and you launch it in orbit to perform this, okay, and it malfunctions. So that is quite dangerous. So um so that is why we have the laser beams. So laser beams is when you have multiple spacecrafts, okay? So they work the same way, but this one we have multiple. We have the multiple spaceships. So they could be in the orbit, they can be sent to the asteroid directly. So they will focus on one spot, heat it up, the jet will begin to come out, and the asteroid path will be changed. So these are um uh the major five mechanisms for planetary defense. So this is our website, and we specialize in this asteroid research. Although we are mostly focused on Africa, but we we can share our knowledge with interested groups around the world. So that would bring me to the end of my presentation. That will bring me to the end of my presentation. Are you there?